This is Kiran. This is basically OpenCV introduction programming. It's not for expertise who has already known OpenCV. So this OpenCV is a basic programming. It describes the how to execute the function and how to load the image and how to display the image, and we finally did how to destroy the created window which is having the image. Basically very simple programming, but whoever the not known and every black hole is unknown thing is very who are very new to this programming OpenCV, it will useful for them. So yeah, now coming to the point, it's load. There is a we need to import. That is include the standard function header file and also the whatever the this is all inbuilt OpenCV computer vision programming related. These are all header files. Now coming to the CV and the STD. CV stands for CV is a namespace and STD both two or a namespaces. All OpenCV, most of the functions and classes and data structures are declared inside the namespace of a CV. So CV is a basic basic functionalities which are exposed by which will provided by standard function header files. Those are will access by and tightly binded with the CV namespace, so that we will access by the CV namespace. So that is the mandatory. We need to use that one to access all the OpenCV functions and classes and data structures are which are declared inside the CV namespace. So those are all must, and you have to use that namespace. Example like we can say that mat is in future we will know that will take another sessions related to mat. That is mat is a simple a class. We can there is inbuilt class, so that class we can access by using the CV. There is a hard and whole the class which is hold the memory of the image. Earlier I have a classes related to basic introductions of a channel. So in the case of mat is a class, so each mat contains nothing but contains channels. So channels it might be a dimensional or different channels. It contains it can hold the based on the image it can hold, and we can define as a channels in that, like in case of a gray we can go with the 2 and 1, and we can in the case of color we can go with the 3 channels, and if it is a alpha then you can go with the more than 3. So we will come to the point related to mat is basically here. Ignore about that currently. Mat is currently as a object which holds the image now, and also we are handling the exception, like, and if something in the case of reading process, so if something that would corrected or anything, that image would be the empty. So image dot empty. So if it is empty, then we can handle in this way. Now now I would like to explain about the image read class also. So now when I mouse over, now you can see that the image read function returns the mat object. So this image read function contains a string, a file name, and a flag. Here the flag contains the unchanged, grayscale, and color. That means image read underscore unchanged, image read underscore grayscale, and image underscore color. Unchanged, the image will be loaded as it is. If you want to get the alpha channel in your input, if it is available, you have to use that flag. That flag is nothing but how to define that image read underscore grayscale is nothing but black and white, so it will load into as a black and white color. So basically in the behind the scenes there would be a 101010 that it will appear that you in future you can see that behind the scenes logic and how we can apply the, and what happened when it is a black and white image, how it will be displayed in the cells wise in that way. But in the current flags there is a image read color which I have mentioned, that is blue, green, red. It contains the 3 channels. That is a color image, it will load into the color image. So if you want, we can use in that way. In the image read we have a option called a alpha. So alpha channel. So alpha channel in a graphics, in a portion of each pixel data that is reserved for a transparency information. We can say it is a mask. That alpha channel is nothing but is a mask. So basically we have three channels for the color image. One is red, green, blue, and the extra one is called a mask, that is nothing but a alpha channel. So each red, green, blue, each is a 32-bit. So 32 extra one, each red 8-bit, green 8-bit, blue 8-bit. So 3 into 8, red, green, blue is 3 into 8, 24. That extra mask, I mean it will cover up, and we can see that mask kind of things in animations. So basically if you want on the image, if you want to apply the name, then the mask is nothing but a alpha channel. So that is a extra channel, that is the 4th one. So 4 into 8, that is a 32-bit graphics. So then in that case the alpha channel will take a 32-bit, that is a 8-bit extra channel is a mask channel, remaining 3 is red, green, blue, that is a color image. So this way we can behind the scenes explain about the alpha channel. Now coming to, this is related to IM image read function, which contains the it accepts a string or file name and flags which I have mentioned, that is image read underscore unchanged and grayscale and color, which returns the matte image. So and also once it is loaded, we can check whether it is empty or not. Now coming to the name window, window of the name, and which contains this image, and we can assign a name window, a name of the window. And image show, here image show is a function which accepts the name window and the matte object. Matte object is nothing but image which we already got from the image read function. So image, now once it is image show function has appeared, it will pop up the image window whatever we are having. And wait key is nothing but this wait key and count count on all we can get from the std, the namespace. The remaining destroy window, and once it is loaded into the memory and once it is shown, then we need to destroy. We can use a destroy window to release the memory and also close the window. Then we can use whenever we want, but in the case as it is a learning curve and it is basic thing, then we are using this and return 0. Then this is a, we are returning 0. There is not a big discussion about that. Now I'm going to execute this.